All right, so before we get into the rest of the identities and everything, we're going to do this last example for this section for the basic identities. And this time we're not going to verify yet. We're not getting to that point yet. But here we're going to simplify this down. Whenever we say simplify, whenever we say that, that means get it down to one trig function. Or get it down as far as possible. So with this 99 out of 100 times, you would get it down to like one trig function. The other time, it might be like you get down as far as possible. You can't do anything else with it. Now, with this, we have to use our identities and try to figure out something that we can do to simplify things down and get it as far as possible. And the biggest part about this is if we look at it like a regular, like let's say for examples, x's and y's, or x's and y's. If we were to look at this problem here and look at x and y's, we should be able to see it really easily. So, for example, let's say we have this. And we're trying to simplify this down. You would know, okay, well, or to, simplify it down. You should be able to say, okay, well, there's a y in common in both of them, and we can factor out a y, and then go from there. Same thing happens when it comes to the sine and cosine, tangent, all this stuff. If we have a sine here in this part here, and a sine here, you can still factor out a sine. You can factor out a cotangent. You can factor out any of those trig functions that are there to simplify things down. So no matter what you deal with, no matter what's going on, you can still simplify. And when I say factor out, I mean things like this. So that means here we can factor a y out, and that will leave us with 1 plus x squared, right? So if you distribute that y back, that would be y plus yx squared. So you factor that out. You can do the same thing when it comes to sine, cosine, tangent, anything, any trig function. So here, that's what we're going to do. We're going to do this part, but we're going to factor out that portion. So I'm going to write this again. Sine x plus sine x cotangent squared x. Because again, with this, you're going to have to know all your identities, because you see a cotangent squared x, that should make you think of one of your identities automatically. So you see sine, you see a cotangent squared, cotangent. Whoa, that I know cotangent squared is a Pythagorean identity somewhere, so something should be able to be pulled out of here and worked like that. So here, let's go ahead and factor out the sine, so it pulls into an identity, out. Oh, not cosine, cotangent, sorry. All right, so here we pulled out sine, we factored it out. We factored out a sine out of both of these, and so we put it in front, and it's 1 plus cotangent squared x. Okay, so again, we're trying to simplify everything down so that we get down to one trig function. So if we look at this part right here, does that not look like a trig identity? It does. So here, let's go ahead and try to figure that part out. This part right here. So we're going to keep our sine x, but what is 1 plus cotangent squared x? What is that equal to? And hopefully you remember, hopefully you wrote it down, look back at, hopefully kind of right now you already know it, but that should be cosecant squared x, right? Because we talked about that on the last example. So we talked about trying to use cosecant to help us to find tangent. So we're pulling that back out again. Okay, so at this point we have sine and we have cosecant squared. Now, things can go together here, can make life a lot easier and all that stuff if you can simplify it down using any of the trig functions to make it smaller, not to make it bigger. So we don't want to go backwards and go from here and go back to this and make it bigger. So don't make it bigger. Don't make the expression bigger. When I say expression, remember this part right here. Don't make that bigger. Make it smaller. You need to make it smaller. So here, there's an identity that we can deal with secant, well, sine and cosecant, which I hope you remember that part too. It's a quotient identity, not quotient, reciprocal, sorry, identity. We know that sine x is 1 over cosecant x, right? Remember that part, right? Right. So you can do that. You can use this to help us to simplify things down. So also we have cosecant x equals 1 over sine. So if we can get things to be similar or look the same, we can get stuff to either simplify down or cancel out. So here, before we actually move into that part, let me do this one step, because we talked about this on the last video, or the last example. If it's cosecant squared x, it's saying cosecant x all squared. So if we have this, we can use this function here, or this portion, we can use that to help us with this. And it can help us to have all signs instead of sine and a cosecant. Oops, let's do that. So here I'm going to rewrite this. I'm going to substitute it in. And I'm going to do 1 over sine x squared. Now, with that being said, 1 over sine squared means that we have 1 squared and we have sine squared. So you can't just say sine and sine cancel out here. Oh, sorry, forgot the x. You can't say sine x and sine x cancel out when you have a square here. We have to do this part here. We got to simplify it correctly. So here, this will be 1 squared, which is 1. And this is sine squared. So in other words, we have 2 sines here. And I'm going to write this out again so that it can be seen so nobody's confused. So let me do sine x. On the top, 1 squared is 1. On the bottom, if we say sine squared, that means we have 2 sines, right? We have 2 of them. So like x squared is x times x, means you have 2 x's. So sine squared means you have 2 sines. And again, just as a note here, side note, SN side note, x times x equals x squared. So when it comes to sine x times sine x, that equals sine squared x, which means you have 2 sines, in other words. All right, so with that being said, our sine x and a sine x on the bottom, one of them cancels out. And we're left with 1 over a sine x. One of the last sine x that's left over. Okay, so we can say, oh, we're done, yes. But again, we need to get down to 1 trig function. And this is a fraction, not 1 trig function. And so if we go back to what we have right here, 1 over sine x is cosecant x, right? So that's our final answer there, cosecant x, down to 1 trig function. Now again with this, you cannot just be like, oh, Mr. Hall, I don't know how to do it, I'm lost. You have to be like, okay, well, cool. I got this. This is perfect. Bam. Okay, I got a train of thought. I can kind of figure stuff out. And also, if you're going through this and you have a plan and it doesn't work right, that's fine. Just scrap it and start over again. With this, you have to take your time to be diligent. You have to take your time to be persevere. I like that word, perseverance. But you have to persevere through all of this stuff. So that's one of our mathematical practices is persevering. Persevere through the hard stuff, even when you're struggling. So with this, you're going to have to persevere. You're going to have to think. You're going to have to push through. It might not even make sense at the beginning, but if you know your stuff, you know your trig identities, things will start popping and be like, oh, wait a minute, that's a trig identity. I can use that here. Or let me try this out. Or if you go down a path and you're like, okay, well, let me try this, and you keep going and it doesn't work out, that's fine. Don't think you have to get it right the first time. Most likely from here, you won't get it right the first time. But you need to make sure that you can go ahead and try something. If it goes bad, try something else. If it goes bad, try something else. You keep trying until you get to the answer. Don't quit on me on this. Do not quit on me. Try, persevere, work hard, push through this. Don't quit, because I can't give you the answer for every single problem because the problems change every single time. So do your best, try it, work hard, try. And after you've tried so many different ways of doing it and it doesn't work out, then ask for help. But try. And you might surprise yourself and get it right. You gotta get up and try.